Hi, my name is Christine G, and I'm going to be talking today about isometries. Um, First of all, we're going to take a look at this star, and you'll notice if I rotated it, let's say I rotate it in the direction a clock would go, or clockwise, that it can map onto itself. So this point would map onto this point, and this point would map onto this point, and so on. And it can lie back on itself completely so that you don't see the star underneath it, basically. Now, it does that clockwise or counterclockwise too. It can rotate counterclockwise and land here on top of itself. And that is an isometry. And here we have a pentagon that has 5 sides, and we could do the same kind of thing where we could rotate it this way, clockwise. Oops. And what would happen would be this point would go to this point, and it would map onto itself. And then we could rotate it again, or we could rotate it this way, counterclockwise, and the same thing would happen. It would be able to map onto itself. Now, if we didn't rotate it all the way to this point, so let's say we only rotated it halfway, well, it wouldn't map onto itself. So it needs to be a certain degree measure that it's rotated in order for it to map onto itself. Okay, and same idea here. So everything has to map onto itself. So this could map onto itself 4 times, because it could go this way and here and here and back onto itself. So, and this angle of rotation looks like it would be a 90-degree angle. So 90 degrees and it would map onto itself, another 90 degrees or 180 degrees back onto itself, and then here again with another 90 degrees, and then here back onto itself. So that's the way the isometry works. And here we have a problem, and where we're asked to determine the isometry that will yield the same image. So where it will map onto itself. And we have a 135-degree angle, and it would need to map onto itself with not every rotation would map onto itself. If it ended up in between, it won't be onto itself. So 135 degrees, the way we figure this out is that we could do it with a protractor, or easier, we could just take the 280-degree rotation, since this is multiple choice, and divide that rotation by the 135. And then let's do that. We can do that in our calculator. So we have 280 divided by 135, and I'm coming up with 2.074 and so on. So here, this does not, because it's not as, it doesn't divide, 135 is not a factor of 280. So we're left over with some decimal or remainder. So that does not work, so we can cancel that one out. Then we take 405-degree rotation. Notice this one was counterclockwise, so that would mean that it would go this way. That doesn't affect it in this case at all. So we don't even have to be concerned with that. This rotation is going to be clockwise, so going this way. But the only thing we have to look for is if 135 is a factor of 405, if it divides it without leaving us with a decimal. And 405 divided by 135, well, that is just, let's see, 3. So this works. So with a 405-degree clockwise rotation, the image maps onto itself. So that would be our answer. But let's check these out. So we have 185 degrees. I'm getting my degree signs on these. and we divide it by 135. We know right away just from looking at this that we're going to get some kind of decimal, and we do. 1.37 and so on. It's rounded, so that one doesn't work. And then 235 degrees, again, we divide by 135 degrees. And what do we get? That would be 1.74 and so on. So this is not going to map onto itself either. So that would be our answer. So that is it. Thanks for watching and hope this makes sense.